In this video, we're going to do some percent yield stoichiometry practice problems. First one I've done here, aluminum and oxygen react to form aluminum oxide. 50 grams of aluminum react with an excess of oxygen to produce the balanced equation above. 90 grams of aluminum oxide is obtained. So what I'm getting, my actual yield is going to be 90 grams. This is always going to be given in a percent yield. They're going to tell you what you have. The theoretical yield is the unknown. That's what I need to do. So I'm going to start with 50 grams of aluminum. I'm not even going to worry about the oxygen here. I'm just going to treat that as an excess. So 50 grams of aluminum with an excess of oxygen. So first thing I need to do is I'm going to need to convert that aluminum from grams into moles. To do that, I'm going to use the gram molecular mass of aluminum, where 1 mole is equal to 27 grams of aluminum. Now, what I need to do here, after I've converted it to that, I need to actually convert that into aluminum oxide. So I'm going to use my mole ratio of 4 moles of aluminum and 2 moles of aluminum oxide there. That I'm going to get from the coefficients, my mole ratio there. Now from here, I am going to convert that into grams. So here I'm going to use the gram molecular mass of aluminum oxide of 102 grams for that. Once I've gotten all that, I can cancel out all of those, leaving me just with grams of aluminum oxide, and that's going to give me 94.4 grams. I'm going to compare that to my theoretical yield. And the way I get percent yield is my actual divided by theoretical times 100, which is going to give me 95.3% yield for this equation. Next up, 500 grams of gold trisulfide reacts with an excess of hydrogen following this balanced equation above. 400 grams of pure gold are obtained. So in this case right here, my actual yield is going to be 400 grams of pure gold. What I need to do for my theoretical, I need to do some stoichiometry. So I'm going to start with 500 grams of gold trisulfide. I'm going to convert that into grams using the gram molecular mass here. Of 490 grams of this is equal to 1 mole. Now from here, I need to use my mole ratio, which I'm going to obtain from up here. 1 mole of aluminum trisulfide is going to react to form 2 moles of gold. Now from here, I'm going to convert that gold into the amount of grams using the gram molecular mass of 197. Cancel everything out, and all I'm left with is my grams of gold. Do the math, and this is going to equal to 402 grams of gold. 400 divided by 402 times 100 gives me 99.5% for my yield. All right. Nitrogen monoxide and sodium hydroxide are going to react using this equation above. I get 6 grams of water from this, so my actual yield is going to be 6 grams. My theoretical yield, that's what I'm going to be solving. So I'm going to start with the 45 grams of nitrogen monoxide. I'm going to use the gram molecular mass and convert that into moles of nitrogen monoxide. Now I'm going to use the coefficients for nitrogen monoxide, 1 water, and I'm going to convert that into how many moles of water I'm going to get. From here, I'm going to convert the moles of water into grams of water, cancel everything out, and what I'm left with will be grams of water. The actual amount is 6.75 grams of that. 6 divided by 6.75 times 100 is going to be 88.9% yield for this reaction. All right, ammonium nitrate is going to decompose into this equation. I'm going to get 163 grams of water from this breakdown right here. So 163 grams of water is going to be my actual yield. The theoretical is what I'm going to be looking for. So I start with 373 grams of ammonium nitrate. I need, of course, to convert that into moles using the gram molecular mass here of 80 grams of this is equal to 1 mole. Convert that using our mole ratios of 1 of ammonium nitrate is equal to 2 water. From here, I can get the amount of water in moles, but of course I need to convert that into grams. So 1 mole of that is equal to 18 grams of water. Cancel everything out, and I'm left with 167 grams of water. 163 was my actual amount. Divided by that times 100 gives me 97.1% yield for this equation. All right. 58 grams of silicon dioxide is going to react with an excess of carbon and calcium phosphate following the equation above. I'm getting 15 grams of phosphorus. What's the yield? Well, once again, 15 grams of phosphorus is going to be my actual amount that I got from there. The theoretical is what I'm going to actually have to calculate. I'm going to start with 58 grams of silicon dioxide. I'm going to convert that into moles with 60.1 grams per mole. Now I'm going to use the mole ratios. In this case right here, 6 silicon dioxide reacts to make 1 mole of phosphorus. So 6 to 1 there. Now I need to convert the moles of phosphorus into grams of phosphorus to compare to my theoretical, 124 being the operative one there. Cancel everything out, and I'm left with a theoretical yield of 19.9 grams of phosphate. So 15 divided by 19.9 times 100 gives me 75.4%.